Hey, Algebra 2 people, how you been? It's been a while since we got together. Still working on section 6.2 with all these fun radicals. So let's try doing some adding and subtracting. And let's see what you know first and see if we can apply that to the new here. So you know when you're adding like terms, let's say you have 3x minus 2y minus 6x plus 7y. You know to combine the like terms. So for instance, you know the x's would come together and the y's would come together as well because they have like terms. But radicals do the same thing. So let's try it out. So on example 5 in your 6.2 packet, let's see what we got. Letter A here. I'm not sure what this is, but we'll find out shortly. So you have the fourth root of 10, and there's a 1 of those, right? This was 1, and 7 fourth roots of 10. Well, these are like terms because you have fourth roots of 10. This could be like the x. And you have 1x plus 7x, x being the fourth roots of 10. So 1 plus 7 is 8. You have 8 fourth roots of 10. So hopefully that seems to make sense for you. Now they have written as a rational exponent, like a rational fractional exponent. Again, this could be written as 8 to the fifth root, correct? But it's written as a fraction, so this one also could be written as 8 to the fifth root, but they're not. So there's fractions, and we can just work with them as just like they are. So the 2 and the 10 will be added together. It's like 2x plus 10x. So 2 and 10 are 12. And then we have 8 to the 1/5. You got me so far? Okay, now this is where things change a bit. This 54. Well, and it's in red, so you're probably thinking, all right, this would be something special, and it is. The 54 and the 2 are not like terms. They're both cube roots, sure, but 54 and 2 aren't the same. So now you got to become an investigator and think about, how can I reduce that 54 to be a 2? And use that cube root to help me. Well, we know that 54 is 27 times 2, sure, and 27 is a perfect cube root. So let's see if we can make that happen. So if I break that into 2 here, so it's going to be cube root of 27 times 2 minus the cube root of 2. And remember, you can split radicals, so we'll split the radical. Cube root of 27, cube root of 2 minus the cube root of 2. And now I got this cube root of 2 thing going, which sounds like they're going to be like terms. But what is the cube root of 27? Well, we've had that plenty of times. And it becomes, because we have been together consistently over the last few weeks, we haven't had to practice with these on a daily basis to get good at them. But hopefully most of you recall that that's a 3. And it's just going to be times the cube root of 2 minus the cube root of 2. Well, now you got like terms, cube root of 2's, right? And there's a 1 in front of this. So 3 minus 1 is 2. Cube roots of 2. Again, you have to find or break that down using the root structure and products. Take some practice, right? Let's see what we got below here. We got one down to the right here, number 9. Looks like I did this earlier, so I'm going to erase what I got here. I'm not sure what the 5 is, but we'll start from scratch. So again, cube root of 5, cube root of 40, yeah, not like terms, right? Well, factors of 40. And I know that 5 times 8 will work, and the cube root of 5 will help with this cube root of 5. So I kind of like that. I'm going to do that. Let's see what it looks like. So I have cube root of 5. Again, if you want to write here, there's a 1 in front of that. Plus, I've got cube root of 8 times cube root of 5. 8 times 5, it's 40. Oh my gosh, look at that, cube root of 8. That's one of the easier ones. Hopefully you recognize that as 2. Again, 2 to the third power is 8. So we can make that a 2. So we have this 1 cube root of 5 plus 2, that becomes 2, cube root of 5. Well, we got like terms. Cube roots of 5. 1 plus 2, 3 cube roots of 5. That's it.